Hi, my name is Amit. I'm on a mission of making AI so simple that anyone can understand it. In our last few episodes, we have talked about a technique called bagging. Bagging is basically to reduce the overfitting in the model. In this episode, we are going to talk about another technique called boosting. So let's see that by an example. Just to recall, bagging was a technique where we were taking a low bias and high variance. So we were taking a collection of decision trees and then we were applying bagging to get a low bias and low variance model. On the other hand, boosting is a technique. We have high bias and low variance model and then we have to convert into, boosting is also an ensemble technique where we take collection of models and then collectively give the result. Let's say we have this training data and we train one model on top of it, then we will get some error, let's say even, and then we will take another ML model and then train the same training data, but this time we pass this error also as an input so that this M2 model is careful for all the misclassified points. Here also some error comes up, let's say E2. Then we will take another ML model M3 and then the same training data which we started with, we will train on it and pass this E2 error, and we will keep on repeating this process until the number of estimators we have decided for this ensembling technique reaches. But then here a genuine question, let's say it's an ensemble technique, so there will be outputs from each of these models. So how do we take the output? In bagging we were saying we were just taking the majority, but in boosting it's a little different. What do? We assign each model a score. We call it alpha. And based on the error it makes, this score will vary. For example, if M3 model makes less errors, then alpha will be high. And if M1 model makes lot of errors, then alpha will be very low. So this is how we write the final equation: alpha times M1, alpha 2 times M2, alpha 3 times M3. And then whatever answer comes, that will be the final answer. So whatever model makes the highest error will have lowest alpha. Whatever model makes the lowest error will have highest alpha. In this concept, there are two algorithms. One is called XGBoost, another is Adaptive Boost or AdaBoost. In our next episodes, we will talk about these. If you have learned something today, then save this reel and follow for more such content.